Okay, so in a simple model, the value v pounds of a car depends on its age, t, which is measured in years. And we've got the following information available for car A. Its value when new is £20,000, and its value after 1 year is £16,000. So we see here the value is going down, which would make sense in the context of the question, because when you buy a new car, after time the value will eventually go down. So part A says we need to use an exponential model to form for car A a possible equation linking V with T. And this is a 4-mark question. Brilliant. So the first thing we're going to write down is V equals A multiplied by E to the power of K multiplied by T. So this is our general exponential model. And what we're going to do, we're going to work out what the constant A and what the constant K are using the information from these 2 bullet points up here. Okay, so the value when it's new is £20,000. So when it's new, there's going to be no age in it. So then T is going to equal 0. And after 1 year, T is going to equal 1 because we know that T is measured in years. So use this information here. When car is new, we've got the 20,000 equals A E to the K multiplied by 0. And we know anything to the power of 0 is just 1. So that means you just have A multiplied by 1. So therefore, A equals 20,000. Brilliant. So we can write our updated model here. So we have V equals 20,000 multiplied by E to the power of KT. So now we need to work out what K is, and we're going to use the second bullet point for that. So after 1 year, the car is worth £16,000, and that equals, so we worked out that A is 20,000, and that's multiplied by E to the power of K, and then we know that in this case T is 1 because the car is 1 year old. So then we've got the 16,000 equals 20,000 multiplied by E to the power of K. So we're going to make E to the K the subject. So divide 16,000 by 20,000, which gives us 4/5. And now we want to make K the subject. So what we can do is take the natural logs of both sides. So if we do the natural log of E to the K equals the natural log of 4/5. What then happens is the natural log of E just becomes 1. So we've got that K equals the natural log of 4/5 like this. And actually if we evaluate that into the calculator, so just put the natural log of 4/5, we get, I'm going to put it to sort of 3 decimal places, we get minus 0.223. This is a good sign. It makes sense we've got a negative number here because as we know the value of the car is decreasing as the years increase, which means we've got exponential decay here. For that to happen, we know we're going to need to have a negative value for K in our model. Bring all this information together, we can write a possible equation that links V and T. So we're going to say V equals 20,000 multiplied by E to the power of minus 0.223 T. And that is our final answer. So having a quick look through to see where we get the marks. We get the first mark for using a model such as this. We get the second mark here for substituting in that T equals 0 and V equals 20,000, working out the correct value for A. We get the third mark here for substituting in that T equals 1 and V equals 16,000 and working out a value for K. And we get the final mark here for getting a correct equation that links V and T. So look at part B now. It says the value of car A is monitored over a 10-year period. Its value after 10 years is £2,000. And part B says we need to evaluate the reliability of our model in light of this information. And this is for 2 marks. So first you're going to see that it's a value after 10 years. So we're going to need to look at when T equals 10 because T is measured in years. And we see down here I've written our answer to part A. So this is the model we created in part A. The first thing I'm going to do is just look at what value would our model say the car should be at after 10 years. So I'm going to say V equals 20,000 multiply E to the power of minus 0.223 multiplied by 10 because we're looking after 10 years. and putting that in the calculator, we get £2,150. Okay, so in the question it tells us the actual value after 10 years. And the actual value of car A after 10 years is £2,000. And look, these are actually quite similar. 2,150, which is what our model suggests, is approximately equal to £2,000. And in fact, £2,000, if you put 2,150 to one significant figure, you get £2,000. So I'd say, therefore, our model is reliable. So looking to see where we get the marks, we get 1 mark for our working up here, so substituting in t equals 10, and then getting v to equal 2,150. And we get the second and final mark for our conclusion here, saying because they're approximately equal to each other, the model is reliable. Right, so we're going to have a look at part C. Now the following information is available for car B. It has the same value when new as car A, so the same value when t equals 0, and its value depreciates more slowly than that of car A. And part C says we need to explain how we could adapt the equation found in part A so that it could be used to model the value of car B. And that is a 1 mark question. Now I'm quickly going to write down to remind us sort of the general exponential model. So that's v equals a e to the power of k times t. Now the key bit of information that we've got given in the question is that car A and B both have the same value when they're new, so when t equals 0. That means we know for the model for both car A and B, it will have the same A value here, so it will be 20,000. So the only other thing that we can adjust is the k value. So formally writing this down, we say that the A value will be the same for car B, since car A and B have the same value when new. So we're going to adapt the equation really by changing the value of k. Now the key bit of information here is that the value depreciates more slowly. Therefore, our k value will need to be closer to 0, so less negative. So the more negative the k value is, the quicker the value would depreciate. So we want to reduce the k value to be closer to 0 than for car A, which is minus 0.223. So writing that out, we want to make minus 0.223, or the k value, less negative. That's all we've got to say to get the 1 mark for part C.